Today we are going to see about the simulation of inductive circuit. We know that here a inductor is connected in parallel with the AC source, and this inductor will withdraw a current which lags the voltage by 90 degree. So theoretically that inductor will withdraw a current which lags by 90 degree. So this is our theoretical concept, and I show you the waveforms which indicates the current drawn by the inductive load. And here you see that there are three waveforms are there. One is voltage and another one is the current. So here the current is indicated by the red color waveform, and another one is the power. And here we are looking into the voltage and current, and when you are seeing that voltage and currents, so there is a phase angle difference. So here that current exactly lags the voltage by 90 degree. So you see that. So this is the positive half cycle of the AC voltage waveform or sinusoidal waveform, and here the current withdrawn by the inductive load lags 90 degree by the voltage. So this is clearly shown in this image. And when you are looking into the phase angle difference, so that is shown in the left side of the figure. So this is the Vm, this is the voltage applied to the inductor, and this is Im, this is the current withdrawn by the inductor. So these two are displaced by 90 degree. Okay, so pi by 2 is equivalent to 90 degree. So pi is equal to 180. So 180 by 2, so that is equivalent to 90 degree. Okay, so this is going to check in the, I will going to explain with the simulated model. So I used the MATLAB 2019A version to simulate this model. So here you can go to the new model. So click on new and click on Simulink model, and it will ask about creating the model. And now I clicking the new model, so this window is opened, and here this is the library browser. So you can add the components required to simulate the circuit. So here I need a AC source, so AC voltage source is available, so you can add with the model. So when you are adding, so that component will come into the model what you opened earlier. And I need a inductive element. So that element is available on the elements option. So when you click on elements, you can see the different types of components. So here I need only the RLC branch circuits, so you add it. And here that RLC, that three components are available. I need only the two components, one is R and L. So here I can feed the value for this as 5 ohm or 100 ohm or whatever you want, you can feed. And here I am giving the inductance value, so that may be fixed as anyone, and based on your requirement or based on the current. Okay, now I am applying this, and I don't want this capacitance, so I am giving it as infinity. We cannot give it as 0, so I am giving it as infinity, and I am applying. So if here you can see change that I need only RL component, so we can choose only the RL. So we can choose only the RL. So now you see that RL component is there. The another components are removed, and I need voltage and current measurement blocks which are available under the measurement category, current and voltage measurements. So I can just track and drop that component in the model also. So here voltage measurements. and I need a scope to see the waveform, so I am going into the SIMS option, and here you can find the scope to measure the voltage and current waveforms. And here you see that so we need only the resistive component, so you can change it to resistance. Sorry, we are going to simulate only the inductance, so I changed it into inductance. So here 100 millihenry microhenry is connected, 100 millihenry is connected, and now I am going to connect these blocks in series with the inductor. And voltage source, voltage measurements in parallel with the inductor. Okay, so I added the required component and I am going to connect the scope. I need two input scope, so I am changing the input ports of the particular scope into 2, because I need two input ports, one for voltage and another one for current, so I added. So now you can connect this with the output terminals of your current and voltage measurement block. And I need inductance, or I need a power guide to measure the to run this block. So here already I added with another MATLAB model, so I am copying it from that. So enlarge this, and fundamental blocks, I go to the fundamental blocks and you can find the power K. So I added with the model simulated pure resist inductive load, and now I am changing it into a discrete solver, so that discrete is enough. And now I am changing it into 230 50 Hz, because our AC is 230 50 Hz. So I added. Now I am running this model, and the model is, and it is showing the waveform. The model is red and it is showing the waveform. And now I am going to extract only the x-axis component to show you the graph exactly, and how the current is varying with respect to the voltage. Here you see that there is a phase angle difference in between the voltage and current, and in order to enlarge the current I am going to reduce the magnitude of the reduce the value of the inductance to increase the current rating. So now you see, now you can clearly see the phase angle difference between our voltage and current. You see that blue color line is the current and this is the voltage. You see that there is a phase angle difference in between our voltage and the current. So this is our simulated output waveform, and by this we can study the concept of inductive load, resistive load, and other things. Thank you.